I'm Anil Kumar. In this particular video, we'll try to understand how to simplify rational expressions and write restrictions on the variables. We'll take a few examples, starting with very simple ones, as you can see here in this particular screen. So we are talking about rational expressions, simplify, state restrictions on the variables. We have three examples here. First one is 9 minus 12x divided by 3, 4m minus 6 divided by 10n, 9ab square c divided by 6a square b. All these lowercase letters which I have shown here, these are the variables, and you get restrictions when denominator becomes 0, right? So let's begin with restrictions part first, and then we'll simplify it. And that is how it should normally be done. So let me write down restrictions first, right? In the first case, denominator is a constant 3, and 3 can never be 0, right? So here we have no restrictions. In the second case, denominator is 10 times n. Now 10 is a constant, but n could be any number. It's a variable. So we have a restriction here that n is not equal to 0. So the denominator cannot be 0. You cannot divide any number or an expression by 0. That leads to restrictions. In the third example here, 6a square b is the denominator. A is not equal to 0 and b is not equal to 0. So these become the restrictions, right? In the first example, since the constant was there, just the constant, we had no restrictions. But there could be times when you could have a rational function of the form. Let me give you an example. Let's say x squared plus 1 in the denominator. Let this be number 10, for example. Here you see x squared plus 1. Now x squared plus 1 is always greater than 0, right? So let me write here, since x squared plus 1 is always greater than 0, right? No restrictions. I should have written that x squared plus 1 is never 0. Okay, since x squared plus 1 is never 0, we have no restrictions here. Right. Let me elaborate on this, since that is one of the most important parts where at times you can make a mistake. So let's concentrate on things which can help us avoid mistakes, right? So when I say x squared plus 1, we are looking for a parabola which kind of could be sketched like this. There are no x-intercepts. There are no zeros. So denominator is never 0, and therefore there are no restrictions, right? Keep that in mind. Okay, so I hope the restriction part is very clear. Now let's concentrate on simplifying rational expressions. So in the coming screens, I will not describe restrictions, but just state them, okay? Now let's talk about simplifying them. Simplify really means 2 factor and then cancel out common factors. 9 minus 12x, we can factor 3. 3 is a common factor, right? So we could take 3 outside and write this as 3 minus 4x divided by 3. 3 and 3, once you have common factors and they are same, they can be cancelled out. Do you see that? So we could write this expression as equal to, let me write down, 3 minus 4x. And it's very important to state, well, there are no restrictions, so 3 minus 4x is an equivalent expression for the given rational expression. So you may also come across terms like equivalent expressions, okay? Let's move on to the next one. Factoring the numerator, 2 is a common factor, so let's take 2. And we are left with m minus 3. Denominator is 10n. Now here you could simplify dividing by 2, so you get 5 in the denominator, and therefore I could write this as equal to m minus 3 divided by 5n. Restrictions are that n cannot be equal to 0. When you write, you can write like this, comma and n not equal to 0. That means these two rational expressions are equivalent, right? So we're also looking into what are equivalent expressions. Okay, the next one here is kind of straightforward. We could cancel the terms which are common in numerator and denominator. So one of the a's, one of the b's, and as far as the numbers are concerned, you could divide by 3, giving us 3 and 2. So here we can write the rational expression as 3bc, right? 3bc divided by 2a. Correct? So in this particular case, a and b cannot be equal to 0. So we can write here where a is not equal to 0 and b is not equal to 0, as I mentioned earlier. Only when you include the restrictions, the simplified version of the rational expression is equivalent. If you don't include this, then it is not equivalent. Perfect? Okay, let me correct this. Okay. Let's move on to the next screen. I hope you've got the concepts. We can go a bit faster. 6x minus 9 divided by 2x minus 3 is the first rational expression on this screen. What is common here? 2, right? So let's take 2 common. Let's write equals to 2 common. We get x minus 3 in the numerator. And in the denominator, what do we have? We have, if I take 2 common, I should have taken 3 common. So there is a mistake here. So let me correct it. So actually it's 3 is common. So let me take 3 common, and what we are left with here is x minus 3 times 3 is 9. Okay. And in this particular case, denominator is 2x minus 3. Now here you can see that we really do not have any common factor in the numerator and denominator, so we cannot simplify it. Do you see that part? However, we have restrictions, and to find restriction, we have to equate denominator, which is 2x minus 3, to equal to 0, and it cannot be 0. That leads to restrictions, correct? So we write 2x minus 3 is not equal to 0, and we can simplify and find what x should be not equal to. Taking 3 to the right side, dividing by 2, gives us restrictions. So we can write here that the restrictions are x is not equal to 3 over 2, correct? However, simplified version is the version itself. It cannot be further simplified. So there could be rational expressions which may be given in the most simplified form, as we have taken in this particular example. Okay, so let's move on to the next. Here 7x is common in the numerator, so we'll take 7x, and we have x minus 3. In the denominator, we can take 2 common. We are left with x minus 3. So x minus 3 is a common factor in numerator and denominator that can be cancelled, leading to 7x over 2 as a simplified form of the given rational expression. Now tell me, what are the restrictions on this? Well, if you look at 7x over 2, you may not find any restriction. What you should do is, you should check before cancelling the common factors. So you know x minus 3 should not be equal to 0, and that means x is not equal to 3 is the restriction. Do you see that? So you can write this as equal to 7x over 2, where x is not equal to 3, correct? Now it is an equivalent expression. Let's do the last one on this page, which is 2x minus 6 divided by 3 minus x. We can take 2 common. So if you take 2 common, you get x minus 3. The denominator, however, is 3 minus x. Can I cancel them? That's a big question. Many times that has been asked. What I can do here is, I can take negative common here, right? So if I take negative common, I will write x minus 3 as 3 minus x. Do you see that? Now you can see we exactly have 3 minus x in numerator and denominator. They can be cancelled. And it results into minus 2. Got it? So this rational expression is equal to minus 2, where the restriction is that x is not equal to 3, since that will make the denominator 0. Got it? So that is how you write restrictions and simplify. Now there was no need to do this step. At times you could do directly, observing that this is negative of one another. Few more examples to go. Here is dealing with squares and cubes. We have three expressions here. The first one is 1 minus x squared divided by x plus 1, 8 plus x cubed divided by x squared plus 4x plus 4, 9b squared minus 4c squared divided by 6b plus 4c. You can pause the video, answer this question, and then look into my suggestions. Now in this particular case, we might take few formulas. So let me give you a few formulas which can help you to factor numerator or denominator, right? So here we'll use what is a square minus b square equals to. It is a plus b times a minus b. In this particular case, we'll use the formula what is a cube plus b cube equals to. It could be factored as a plus b times a square plus ab plus b square, right? And you will also see that part which could be factored as a plus b whole square equals to a square plus 2ab plus b square. It's a perfect square. Taking help of these formulas, you can factor numerator and denominator, simplify the rational expressions, write the restrictions, and then check with my solution. I hope that helps. Okay, so let's move ahead. So here 1 minus x squared is like a square minus b square. A is 1, x is b. So we could factor this as 1 minus x times 1 plus x. It could have been written 1 plus x times 1 minus x. Commutative property, correct? Okay, x plus 1. And clearly x plus 1, 1 plus x is the same thing, and it can be cancelled, right? It can be cancelled. So what you get here is 1 minus x. So the rational expression is equivalent to 1 minus x. But we should know what the restrictions are, correct? Denominator cannot be 0, so the restrictions are x is not equal to minus 1, correct? That's how you should be doing it. The next one here is sum of cubes. Think 8 as equals to 2 cube. Is it okay? So it becomes, the numerator becomes 2 cube plus x cube. And we'll use this formula to expand. So it is 2 plus x times square of 2, which is 4, plus product of these two, which is 2x, plus x squared. So that becomes the numerator, and the denominator is a perfect square. It is x plus 2 whole square, correct? Now you can cancel the factors x plus 2, which leads to the simplified version, which is 4 plus 2x plus x squared divided by x plus 2. Now it is a common practice to write highest degree first. So I am running out of space, so I'm not writing, but you should write x squared 2x plus 4 in the numerator, right? How about restrictions? Denominator, which is x plus 2 whole square, cannot be 0, so x is not equal to minus 2. Do you get it? Okay. Let's do this one. Now here let me write down the restrictions first. Denominator is 6b plus 4c. How do you find restrictions? Now 6b plus 4c is not equal to 0. So you could write this as 6b is not equal to minus 4c, or b is not equal to minus 4 over 6c. And once you simplify this, you can write b is not equal to minus 2 over 3c. Do you see that? So that becomes a process of finding restrictions. Denominator is not equal to 0. So I hope that part is clear, right? So let's move ahead and factor. 9b square minus 4c square is example of difference of squares. We could factor this as 3b, right? Because 3 square is 9, correct? Plus 2c times 3b minus 2c divided by what? 2 is common, correct? So we get 3b plus 2c. Now 3b plus 2c can be cancelled. So you get 3b minus 2c divided by 2. So that becomes a rational expression. This is also a rational expression. Think as if we are dividing it by 1, okay? So anything which is kind of a polynomial, I should say, is a rational expression. Is it okay? Rational expressions basically are ratios of polynomials, as you know, px over qx, where qx is not equal to 0. That leads to restrictions. Perfect. So I hope everything on this page is clear, and let's move on to the last screen. Now we are almost at the end. We have 3 more examples to go. We'll simplify and state restrictions for each one of these rational expressions. The first one here is x square minus 2x divided by x cubed plus x, 2x square plus 10x divided by minus 15 minus 3x, 5x y square divided by 15x to the power of 4y minus 10x square y square. I'll request you to pause the video, solve this one yourself, and then look for my suggestions. Let's begin with the very first one. Let's factor first, okay? So x square minus 2x, x is a common factor. We are left with x minus 2 in the numerator. Denominator, x is a common factor. We get x square plus 1. Now x square plus 1 cannot be factored, right? And it is never 0. Remember that. We began with this, right? X and x, however, can be cancelled. Now we get an equivalent rational expression which could be written as x minus 2 divided by x squared plus 1. And what are the restrictions? X is not equal to 0. So normally when you simplify it, you should write at the end restriction along with the equivalent rational expression. So remember this term, equivalent expression. Now if I do not write restriction, then these two are not equivalent, since this rational expression has a whole at x equals to 0. A restriction x equals to 0, and the one which you have written at the end is without any restriction. Only once we write x not equal to 0, it is equivalent. Remember this. Okay. Next one here is 2x squared plus 10x divided by minus 15 minus 3x. So let's factor. We have 2x common in the numerator. We are left with x plus 5. In the denominator, we can take minus 3 common. We get 5 plus x. As you realize, x plus 5 and 5 plus x are the same things, so they can be cancelled, and we get a simplified form, which is 2x over 3. It's a good practice to write negative here. Now what are the restrictions? Restrictions are that x plus 5 is not equal to 0, so therefore x is not equal to minus 5. Perfect. The last one here, we'll kind of review most of the concepts with this also. It is 5xy squared divided by 15x to the power 4y minus 10x squared y squared. Now numerator is a monomial, right? Just one term. We have 5x y square. In the denominator, binomial, we can take two factors common. As far as the numbers are concerned, 5 is a common factor. As far as the variables are concerned, x square is common and y is common. What are you left with? 15 divided by 5 is 3. X square, when divides into x to the power of 4, you get x square. Y divided by y is 1, so leave it. Minus 10 divided by 5 is 2. X square has been taken out. Y square divided by y is y. So that's what you get. Now we could write this as 5xy square divided by, I should simplify this. So 5 and 5 cancels, x cancels, y square cancels, right? So we just left with y, correct? So let me erase all other things. So that is a simplified version. Do you see that? Just y in the numerator, right? Is simpler than what we started with. And we have 3x square minus 2y in the denominator. Now the question is how to write restrictions for such a question. So let me use the space which we have here to write restrictions for our third example. So I'm kind of utilizing this space for the third example. Okay, it's kind of important. So first, 3x square minus 2y, 3x square minus 2y is not equal to 0, means 3x square is not equal to 2y. That means x square is not equal to 2y divided by 3. And what is x not equal to? X is not equal to square root of, okay, let me push this page a bit, okay, 2y divided by 3. And whenever you do that, you have to do plus and minus. Do you get it? So that is how you find restrictions from the denominator. And there are other restrictions which we cancel. Do you remember that? So let me write down all the restrictions now. So restrictions are 1, which we just found, x is not equal to plus minus square root of 2y over 3. This is from here. And what else? It is not equal to 0. What else? Y cannot be 0. Do you see that? Y is not equal to 0. Do you see that? So these are all the restrictions which you should mention. Now if you want, you could solve it the other way also. What y is not equal to as, but you'll get the same thing. And also, if you see the other way, you could write this as 3x square divided by 2. So y should not be equal to 3x square divided by 2 also. Do you see that? Of course, there's overlap here, right? They are same things. But anyway, there is no harm in mentioning, but these are same things. I hope with this, you have understood what rational expressions are. As we began with, rational expressions are of the form of, a polynomial divided by the other polynomial where the denominator cannot be equal to 0. These are rational expressions. And that denominator not equal to 0 leads to restrictions. Got it. And that is how you should work with it. I hope you have understood something about rational expressions. Sorry for taking so much of your time. Thanks for your patience. And if you like, that'd be great. Share my videos with your friends and share your views. Thank you and all the best.